Recording. Just a moment, I'll. Yeah. What will be the format of the exam? The question. So exam, I am not sure. This you have to mail to that the NP some that group is there. There you have to mail and ask. Exam, I am not. I don't know because we are a PMRF TA and we have only the uh, job. Our main job is to just take these online sessions. There are separate TAs for setting up exam questions and those other things like assignments and all. We are not a part of that. Okay. Um, so and you will start the session. I'll just check if anyone has any issue. Okay. So I'll. Of course, it will be based, the questions will be based on the assignments and all format. I mean, whatever is taught in the class, I think based on that, it will be the questions. I don't think there will be something very like out of the box thing. But yeah, but I don't know the formats and those things. I'm sorry to say. Then, okay, so we'll start from the session and okay. So today I'll be using this is known as a Jupyter Notebook. It's another uh, similar type of Python IDE, and basically it's mainly used. This is more preferable than sometimes to because it's easy to visualize data in this part this ID. And so so it's basically available on the Anaconda. If you open Anaconda Navigator, you'll see that this Jupyter Notebook is already by default installed. So I'll just show you so that you can just just a second. Yeah. So no, remind me later. So as you can see, there is Jupyter Lab, Jupyter Notebook, both of them is there. So you can or launch this. If you launch that, I've already launched it. So it will open in your web browser. Any web browser is fine. It for me, the default web browser is Chrome. So it's opening on the Chrome. It can open in any web browser. Okay. And for setting a Jupyter Notebook, so it will open in our default location. Then after that, you have to go in wherever you want to go and you have to say a new IPython file like this. Or you can say new text folder, new terminal, but I will use new notebook, that is Python 3 notebook. And I have already made one notebook, which is this one. And if you open this, you will get this kind of uh, starting. So so by clicking plus, you can add more and more what this called the cells, more and more cells actually, and you can change the cell type. For example, this is the cell type. I have kept it markdown. I can also keep it heading R raw NB convert code. So for others, I'll use raw NB convert. Okay, for this is heading actually. Okay, so this is my heading and like this. So, and you can run it cell by cell, like cell run cells like that. If you just do, it will not run the whole code, but it will run cell by cell. So if I just say that, okay, A is equal to 3, B is equals to 4, and A plus B, sorry, A plus B, can see that if I just now run this, it will run only the first thing, run, and this give you 7. If you want to run all of them together, you have to just say run all, okay? And it will give you. Okay. So we'll start with our session. So what is Matplotlib? So if you just go in the Matplotlib documentation here, Matplotlib. So it's a visualization tool. Okay, you can plot, you can do multiple types of plot in using Matplotlib. It's a module that's mainly used to plot different functions, different uh, data, and it can literally do any kind of visualization depending on what you want to do. You will use particular types of say functions or um, particular types of functions or particular types of plots. Okay, so we'll start first with the basic plotting. Sorry, we'll first start with the very basic plotting, that is the, I'll again give an heading, that is we'll start with the scatter plot. Okay, so we'll do with the scatter plot or string formatting or scatter plot. Okay, this is one of the most commonly used plot in any kind of data visualization. So here we'll have, say in X, we'll have two types of data. So data can be anything. It could be a NumPy array. It could be a simple list. It could be a pandas data set. It could be a tuple. Okay, and so Matplotlib is mainly used for 2D visualization. I am not very much familiar with 3D visualization. You have to take specialized course or use some different modules for 3D visualization. But this Matplotlib is mainly used for 2D visualization. Okay, so first thing we'll plot some data. Okay, so we have two lists maybe. So let's say I want to see that what are the speed of the say for what do I say something. So okay, so one example I'll want to plot that what is the speed of the speed of a cricket like ball, that is a when a ball is bowled, what is the speed of the ball and how does this change from uh, say in from first ball to the sixth ball in a over. So in a over we'll have ball 1, ball 2, ball 3, ball 4, ball 5, ball 6, 6 over. So each over will have 6 balls. And say we are talking about a fast bowler, maybe Jasprit Bumrah or Lockie Ferguson, who bowl like very fast deliveries. So let's start from say 140, 136, 145, 150, 148. Then we all maybe some of when they have gone a slow ball, so we'll got for a last ball of a 125. It's a slow delivery, slow pace delivery. So then, so what do you do? So we want to plot. This is your X, this is your Y. To have the function that we use is plt dot plot. Oh, sorry, I have to first insert cell above. So I have to first import Matplotlib. So for installing Matplotlib, we have to just say pip install Matplotlib. That's the thing. But I have already install. I have already have it installed, so I'll not reinstall it. Instead of that, what I'll do is we'll do a we'll import the module first. So import matplotlib which is, and inside that matplotlib module, we have a particular class known as pyplot. So we'll import matplotlib.pyplot as PLT. Okay. Then we have a X data, we have a Y data, and we'll just say plt.plot X comma Y. Okay, we'll first have to give X data and Y data. So we are plotting basically Y versus X. And if I now go and say run all, see, now it's gave me a data that how the speed of the ball, how it changed. Okay, if it's like now, say if you don't want to have it in this format, you want to have it in diamond. So basically you can use a string formatter. So how do I say? So I want to say use a plus sign for each of them. So if I now run this, see there's a plus sign here in all of them. I want to give a different color. So for that we can use plus. Say I want to give a black. So I can say black plus. Oh, black won't work. So we have to use the format, maybe B. Yeah, B will be blue. I think BL will be black. No, black will be something else. Maybe I have to check. So you can use red, it will become red, and it doesn't need to be. So this is the pointer, and this are also I want a dash line with that. So I can make like this. See, I got a dash line as well as the pointers. Okay. Maybe I want a green dash line. So I can say that, okay, plus R, then G. This is not working. I have to say R plus, actually, R plus and G minus. Actually, this won't work like this. So we have to do it in a separate format. So in string format, you can do it like this. You can change your order at any moment. So you can give first plus, then R, then first this and this. You may use to, if you don't want to use this one, you can also use maybe O, if this will also work. See, it's big dots like that. Okay. Now these are the things that there's a string format, but sometimes it can get confused as I was showing you. So what we can do instead of this, we can use the specific format. So for example, this is the matplotlib. This is the plt.plot thing. So 1 second. So I'll go is I'll just type here matplotlib dot pyplot dot plot. So it's plt.plot. And we'll go to the documentation here. We'll see there will be lots of things that you can do. There are lots of keyregs. So for example, we'll use color. We can use, say, if you change the color. So if I want to do like this. So instead of making it as a string formatting, I can specify each of them. So color, I want to make it black. If I do this, see it's a black. Now I can say there will be multiple things. I can say that, okay, marker. Okay, we can say marker, we can say line style, line width. So for example, if I say line style, so line style is equal to, maybe I want it dashed. So I can say, see it's a dashed black line. We can also do something like marker. This is the marker. We can go to the marker style. There could be different marker styles. Okay. So we can say that, okay, marker or marker is I'm going to give plus marker. See, I get plus. If I want to give red plus marker color, so you have to use that other thing that is marker color. Okay. Is the marker face color or MFC or marker edge color. So marker face color we can change. So if we say that, okay, my marker face color, I want to make it, sorry, I'm not We want to say marker face color is equal to red. Face color, red. No, 1 second. So marker plus marker. Yeah. So it's the face color will change. We can change the marker edge color also like this MEC. We can do anything, right? So with marker also you can give lots of things, field markers, marker color. So we'll have option of color here also. If I search for color, okay, there'll be lots of colors you can change. Okay. Yeah. And edge color we can also change like this. Oops. If I say this will also change. See, its marker edge color is changed. I am not, I was actually not using face color, using change color. So marker edge color. So marker edge color. You can also change marker size. There will be something known as marker size also. See marker size. So can also use marker size is equal to, say I want a big marker, so I can make it 4. It would be a integer or like any float. Okay, Chila's making it slower, so I can make it a 20. See, it's making a big markers. You can also use line width to change the width of the line. Change the width of the line. So line width, maybe I'm giving it 9. So you can see that, see it's big dots. You can also give, I think you can give OO to give like, sorry, OO to give like, no, O is not there. So there will be different line styles you can go. See, these are different types of line style. This. We can have this dot. Okay, so we will try this one. See, we have this type of line style. Let's go with this. Yeah, it will have a dash and a dot. See, dash dot line styles like that. So there are multiple things that you can use here. Okay, and you can check in this. For example, one of them is alpha. So alpha will control your transparency. So if I make the, say, alpha, by default it is 1. If I make alpha is equal to 0, it basically this line will go off. See, if nothing is there. Now what I can do is alpha equal to, say I give 0.5. It can be anything between 0 to 1. See, now the whole plot has become a little more transparent like this. So you can control many things with this. And also there is, we don't have any labels till now, right? In the what is x-axis, what is y-axis, we don't know. So we can use different, we can use other two commands, that is plt dot x label, plt dot x label, which will be, say my x label will be a string, which will be the ball speed, and my y label will be plt dot y label will be ball number, right? So if I again run this, oops, I have to do run all. Yeah. Yeah, so it's actually basically not putting the same axis. So I have to put in the same one. Yeah. So it will be coming in like, see, ball number, ball speed, anything. So all the plotting things we have to put in the same, what it is called, in a same cell, in a same cell. Okay. So in the same cell, we'll put all the things related to the name. Also, you can control the size of this, like using the command font size, using the argument font size. So I want to make it say 12, and here also I want to make the font size as 12. Okay. Font size is 12. If I now run it, see this thing has increased. Also, you can use another thing, that plt dot title, to give a title to your plot. So my plot title is polling speed in an okay. If I do run this, bowling speed in an over. Okay. So we'll have like this. You can use a different font size. Also, you can use color here also. Color is equal to give red R. So this will change to R. Can also use font size here also equal to, say, I 15 for this. Strength, see, bowling speed and over, ball number and ball. Sorry, I think I have mistakenly X level and Y level. I have mistakenly this. So ball speed is in the Y axis and this is in the X axis. Okay. So this is how we can do a simple scatter plot. You can do many things in a simple scatter plot, but we cannot do that. We'll do that. We can check this with this, and you can play with all the parameters here. There will be multiple parameters. You can check with all of them and try to see what happens. Okay. Like this. Okay. And check on every of them. There will be lots of, you can go and see in the matplotlib.pyplot.plot, which I'll maybe just go and paste it in the chat box so that you can later go and find it. Okay, so I'm pasting chat box. Okay, and anything else? Okay, so I hope this is clear till now. Any questions here? Right? No questions so far? Okay, now we'll go for my second our second thing. We do with, we have all done with scatter plot. Now we'll go for another type of plot, that is a bar plot. Another very important types of plot that we commonly use in our daily lives. Correct? A bar plot. So how does a bar plot look? If you just search in Google that bar plot, you see that this is how the bar plot look. Correct? This is how the bar plot looks. Okay. So it's the height of group 1, group 2, group 3, like that. Okay. You can have rural male, rural female, many types of bar plots you can see. Correct. Now, how to make a bar plot? Okay. So to make a bar plot, say I'll first have two data types. So for example, I have two data. That is the average. Okay, no, but before moving to bar plot also, I need to show you one more small things. So something known as legend. So now we have maybe a single data set here. What if we have a multiple data set? For example, in say this is my, so I have multiple bowlers and I will check a ball speed in a particular in an over for different bowlers. For example, this is ball 1. So this is maybe for Bumrah. I may go for a spinner, Jadeja. Who will have yeah. So with Jadeja, maybe we'll have something like a speed of say it will vary from 80 to 100. So we'll go for 80, 90, 87, 100, 88, and say 96. Okay, this is the browse of Jadeja. And we'll go for another bowler. Maybe we'll go for a medium pace bowler. Maybe we'll go for Mohammad Shami. Okay. And or we'll go for huh, we'll ball around maybe from 130 to 140, 150. So we'll go say see maybe he has gone for a slower ball, then a fast ball, then another ball, 140, the fast bowler, and maybe 142 and maybe 136. Okay, so there are 4 moves. Now I'll plot each of this. So how I will plot them? So what I will do is I'll convert all of. So I have to just basically use instead of X and in Y I have to change. Okay, plot first plus plot Bumrah. I'll copy this and give this. Okay, and for maybe I'll give color green. This will color blue. Okay. So okay, sorry, this is the edge color. Basically, I have to actually this maybe keep everything for see. This is black, blue. Okay. Now if I plot instead of Bumrah, Jadeja, and Shami like this. Now if I just some issue, let me see. Bumrah. Oh, sorry. So now we got like this, and we can instead of making it 20, let's make it 4, 4, 4, and this thing let also change. So instead of say it's I have a black red, I'll be blue yellow combination, and maybe red green combination. So if I now run this, see you can see, and line width also let's make it something like 2 to make it a little easy to visualize and good looking. We can go it with 2. Okay. So this is how I look. Now if I just see this thing, I cannot see that, okay, what is the and let's alpha make it for 1 for everyone. Okay, let's see the visualization. But if I just see this, I cannot see that, okay, who is red, who is black, who is blue. So for that we have to do is something known as label. So we have to label them. So first one is our Bumrah, right? The second label is Jadeja, and third label is Mohammad Shami. Now if I run, we'll still see that nothing has changed. So for that we have to what we have to do is we have to use another thing known as plt.legend. So this will give you a legend. See, Bumrah, Shami, and all. And in legend, you can control many things. For example, I can control the legend's font size to be a little smaller. So I can font size, I'll commit 2. And I can say different locations. So I want to place it maybe in the upper left corner. So you can write upper left. I'm not sure this will work. I have to check once. Yeah, I think it will be upper left. No. Let me just check. These are just small things you have to either remember, or you can always go and Google search what are the options. Go splt.plyplot.legend, and you can go and see what are the legends. So upper left. So it will be, there should be no gap here. So there should be nothing. There should be just space here. See, it's upper left and font size has become 2. I can increase the font size maybe to 10. Rerun it. See, it's in the upper left corner. There will be multiple other. Oops. There will be multiple other options also. Right? There will be multiple other options also. So if I go to the legend, you can see that best, upper right, upper left, right, center, lower center, like that. Okay. There are many other things you can say that what would be the number of columns, number of, so n columns will basically is kind of use how many number of columns you want to put in your you want to put your this one fonts, your legend. You can see label color, num points, many things you can do. Okay, you can just see there and have a look. Okay. Then what we can do? Okay, this is one of them. Some of them we have already seen. Okay. So this is how it will look like, and see, we have now have a legend to show that, okay, what all the this thing are there. Marcus, you can use to 6 to that you can understand better. And instead of this, I can do this. Okay. Okay. See? See, okay. Yeah. So that's more or less everything for scatter plot. You have got legend. You can see through as a legend and like that. Okay. Now we'll go for something as bar plot. Okay. So this is the bar plot. For making a bar plot, we'll have, maybe I want to plot the average, how do I say? Maybe I want to plot the average score of different batsmen in the World Cup. Okay. Say we'll have, so we'll first have two lists. So batsman. So I can always choose it to be any two names. So what I can choose is I can choose like took a list, or I can take np.arrange. So I'll also import numpy also here. So numpy as np, and I have already told you that what is numpy.nb. So np.arrange, sorry, np dot. So we'll give okay. So first we'll get a batsman name. So if you give batsman name, we'll say I'll come to this era only, not Sachin, so Saurabh and those. So I'll say Rohit. I'll say Virat. I'll say Shubman Gill. Who else are there? Hardik is Hardik. Sorry if I am with any spelling mistake. And maybe we can go with KL Rahul. Okay, so Rahul. We have batsmen, different. And we are saying like average scores in World Cup. So we can scores will be maybe say average average score in each match. For example, for Rohit Sharma, it may be 70. For Virat Kohli, it may be 78. Shubman, he's now he's now doing centuries in every match. So maybe we can give him some 120. Hardik is a finisher, so he may not be able to score a very good trend. KL Rahul, average, he is also coming towards some 100, so we can give him 90. Okay, so we have 5 players, 5. So now, if I go to the next thing that, so what we'll do, PLT dot bar. So if I do PLT dot bar and this is my x-axis, my y-axis, if I do batsman scores, should I get my bar plot? Let's see. Oh, sorry, first. Okay, and we are getting my bar plots like that. Okay, now if I think in new Matplotlib, this is now works like this. So previously, if you use Matplotlib, if you put a batsman here and scores here, it would give you an error. So what you had to do is that time. So this is new Matplotlib, so that's why, and in Python 3, I think it can take the automatically converts this thing. But what previously used to give you an error. So if you give if it gives an error, what you have to do is you have to give, say, x-axis. I'll just say x-axis is equal to np dot range of len of my batsman. Okay, you can use simple range of list also. Then we have to do it instead of using this, we'll just first do this. Okay. So see, we'll get a x-axis of 0, 1, 2, 3, 4 like that. Okay. Now what we'll have to do is we'll convert this x-axis 1, 2, 3, 4 or 0, 1, 2, 3, 4 to a number. For that, what we'll do is okay. Good. So what we'll do is we'll do one more small thing we have to do is PLT we'll to do PLT dot xticks. So the first thing will be your tick levels, that will be your x-axis. Second will be your batsman. Okay. Now if I run this, yeah, you can see that it has been replaced, all of them with Rohit thing and all. And what is the advantage of doing this? You will understand in one minute. So now I have plotted, okay, Rohit, Virat, Shubman, Hardik, Rahul. Now I wanted to plot same thing, but for a different. So these are plotted for Indian batsmen. Maybe I wanted to plot same with the maybe South African batsmen. So batsmen, and so we'll have one more similar list, and we'll have like this. Okay. Instead of this, we'll have Quinton de Kock. So Quinton, Timba Babuma. So Babuma. We'll have what are now list. Aiden Markram. Markram is South Africa, I think, right? Aiden Markram. Will whom I'm forgetting. I've become old school. I have become. For me, the names coming is Abby de Villiers, but he is not there. Kevin. So who all is there? Let's search. South Africa. Cricket. Who all are there? Who all are playing nowadays? Okay. Yeah. Quinton de Kock. Okay, Rassie van der Rosen. Yeah, Rassie van der Rosen is there. David Miller. Good. See? So we can go for Van der Rosen. Okay. Van der, his name? Rassie van der Dusen. Rassie van der Dusen. Okay. And we'll call David Miller. Oh, Miller. So I don't know. I'll just give some arbitrary numbers and I'll give, say, maybe 50. No, Quinton is playing. Quinton is a good player. So we can give him 80. Tim Babavuma. Let's give him, say, 7. Keep him, say, 3. And give him, say, Aiden Markram. We can give him a finisher. So we can give him 45. Van der Rosen also good player. So let's give him 65. David Miller also kind of finisher. So give him 65 also. Now, see, and yeah. So again, if I now do a same PLT dot bar, I gave, say, this will be same. Instead of scores, I'll be scores SA, batsman SA, South Africa, scores SA. And we can also give PLT dot sticks. First, we have to do this. Okay, I give PLT dot bar for the second thing. That is, this is not a score. This is a score. This will be correct. So we'll give, and again, x-axis, and we give scores SA like this. Now, if I run this, scores SA is no, okay, sorry. Yeah, this is run. Okay, so now as you can see that they have been fall. The bars have been fall on top of each other, and if you just go for same thing, we'll do for batsman SA. Okay, so they have been fall on the same bar, correct? So how do I change this particular thing? For that, what we can simply do is we can do a plus minus. So we can do +2. And here we can see go to -2. If I do this, little better, right? Something wrong is happening here. Just let me see. Sorry. Actually, this I cannot change, right? This is my bad. Sorry. So this I cannot change, right? So say I want to okay. So basically this I cannot change. Sorry, my bad. I just did something wrong. Just let me see one small thing. I think I'm doing something wrong. Uh, just a second. So I think I'll just check in the Matplotlib.
Sir, the screen is not visible.
Yeah. 1 second. So actually I did it purposefully only. So actually what I'm sorry, I was doing simple things. Say maybe I'll not do this instead of actually I'll do because one small wrong thing I'll do. Say maybe we'll say that okay, scores in versus maybe I'll say scores versus Pakistan and we'll say score versus in the South versus South Africa. Just average we are doing, okay, small average. Let's see. So we want to plot both of them side by side. Okay. Want to plot both of them side by side. I can delete this cell. Delete. Okay. So if I now do this, scores. Actually, I was doing it wrong. So one small thing I was doing wrong is that. So I'll do two bar plots. So plt dot bar will get like scores pak. Now, if I do like this, what will happen? I'll show you. Batsman. I'll do in the my previous way and plt dot bar scores versus South Africa. I'll do same batsman. Now, if I run this, it's not defined. So yeah, if I now run this, as you can see, some problem. Sorry, this will be my. I have mistakenly x-axis y axis have mistaken. So no, this will be my this will be my y-axis. So batsman and batsman like this. Okay. Now what is you can see is that the both of the bars are falling on top of each other. This we now how to solve this problem because I want to be side by side. I cannot see what Rohit has scored against Pakistan. Okay, average score against Pakistan. So what we can do is we will use this particular thing. Now what I'll do is instead of using uh, batsman, I'll use this x-axis. Okay, and now if I do +2 -2 like this, see it's much better, right? Much better. It's not the still not the ideal. Hmm, good. It's not the ideal. So what we can do is plt dot x ticks and do it. Say we'll go what you are doing previously. X-axis, comma, batsman. No, there is something wrong I am doing. Just give me one moment. Let me check what's me 1 minute. I'll figure this out. I think I'm doing something wrong here. Hello. Yeah, actually, I was doing wrong in one thing, that my x-axis should not change in such a manner that basically you have to change it in a very small number. Actually, yeah, that's how it will work. Actually, I was changing in it's in a very high number. So I was doing everything correct only, but I was changing in it a high number. That's why what's happening. So what was happening, basically what this is doing. So let me just comment this out so that you understand actually what is happening. So I have 0, 1, 2. In 0, I have so I'm plotting basically 0. At position 0, I'm plotting scores of Pakistan as one like uh, 70 and scores of. So 0 is basically Rohit's score, 1 is Virat's score, 2 is Shubman's score, 3 is Hardik's score, and 4 is Rahul's score. Now what I am trying to do here is I have to do a little bit of, so what I'm doing with by creating this +2 and -2, I'm shifting their position a little bit. So I'm just going say 0.2, 0.2. So just a little bit so that these bars separate from each other. Okay. So if I do like say +2, what is happening? 0 is now coming to 2, 2 is now coming to 4, something like that. So you have to do it in a very less amount. Basically, the difference between this. See, if I could have done this, if I have done is like maybe a difference that will be say 0, 4, 6, 8, something like that, then I may have done that 0, 4. So what I'll do is that's why I was getting this problem. Okay, now what I'm doing by using X sticks, I'm basically saying that 0 is Rohit. Okay, make 0 as Rohit, make 1 as Virat, make Shubman. If I do now run this, see, much better. But what we'll have to do, we have to control the bar width. So we'll do the bar width maybe like, I don't know how, something like, so you can say it like 1, it looks much better. Okay, 1 is too high, I think. So you have to go maybe 0.2, 0.2. Yeah, much better, right? So we can go up to maybe 0.5 to 0.5 to make it kind of a, okay, kind of. So like we have to change these things a little bit and play with this basically to make it exactly what we like to. Can you, someone is, yeah, okay. Now it is good looking good. So we can see that Rohit has scored more against South Africa, Shubman has scored more against Pakistan, and something like that. And here there are, okay, something like that. And okay, so it's kind of this built bar. So you have to basically what I'm doing, I'm shifting the bars a little bit so that I can do different, like make sure that two scores are different. I'm just playing with this thing to make it like 0.4. You can make it is like 0.5, 0.7, make the width of the whole thing higher. Okay, this is how the bar plot is looking like. Okay. Now this is more or less, and also we can write a legend like similarly, we can use those things like label, maybe we can label this is the course against Pakistan, and we can similarly do something like this, like course against Essex. Okay. And we can say plt dot legend similarly. Okay, scores against Pakistan, scores against South Africa, right? So this is how the this is how the bar chart, mainly the bar chart or bar plots work. Okay, when also plot horizontal bars, similarly you have to just say that bar h. Okay, instead of bar you have to do bar h. Second bar h called multiple values. Oh yeah, here you cannot put width thing here. So for the bar h, the I think it was the height. Got multiple values again width. Anyway, we can just put it separately. Can also do it like this. So you can have a height chart also. Okay. And something like that, but you have to change the x-axis and y-axis for this. That's why it's having problem. Basically, you have to first put the x scores Pakistan x and make it x-axis minus 0/2. You have to move these two, is like interchange these two. That's why you are having the problem. Okay. Okay. Then. And next we can go and have a look at the histograms. Okay. So we said go to the another thing known as histograms. Okay. So how does histograms look like? Okay, sorry for the there's some phone call. Um, yeah. Now we'll make histograms. So what is histograms? Histograms are basically bar chart which will have frequencies in this y-axis. For example, if I search for an histograms here, and go to some images in Google like this, we can see that tree circumference with the trees that have circumference of 150 from 100 to 150, there are 12 trees, and in the circumference of 0 to 50, have there are 6 trees, something like that. Now, each of this particular range is called as bin. Okay, and this in y-axis there will be frequencies, and this bins there will be a particular range to range variation. So each of this is known as bins. One of the most common histogram things that we come into our daily life is grades in a particular class, right? So one of the most common thing. So we'll say, okay, we'll have a grades. Okay, grades will have a list of grades. So in 100, so we'll go from say 70, we have something like 70, 67, 56, 78, 45, 78, 98, 76, 99, 45, 32, 67, 45, 87, 66, 75, 87, 86, 65. We can have like multiple. I'm just to give it like, sorry, 45, 15, 24. Okay, I've got a huge number. I think I've got enough set to make it make a histogram like this. I do some more. Something like that. Okay, we have a grade of students. We have a huge number of grades, and we want to make an histogram. So if I just plt dot hist and do a grades, there's some invariant syntax here. Oh, there is a 2 comma somewhere. And give some another score. See, we have got a grade cut chart, and like this. So there are only one people within 20 to 40, 40 to 60, 60 to 80, 80 to 100. Now by default, we have got some bins. Now say we want to give a bin. So I want to say people who have got from 0 to 20. Yeah, 0 to 20. Or I want to say see that people who have got say it's a got a 2020. Instead of that, I want to make a 1010 car beans. So instead of this, I can say something known as bin size is equal to, I can make, if we can make 10 bins, right? One second, I'll just check the bin size is plt dot list. And type bar stack things, R width. One thing is R width. Is that R width? Please ignore this. Means why? Yeah. Bean size is beans is 1, 2, 3, 4. Yeah. So we can make beans like this also, or we can do beans like this. Not bean size, sorry. The thing is that we have to do a thing known as beans and make a list inside. So we have to make 0, 10, or we can say np dot range from 0 to 100. Actually 101 I have to give, 110 rather. So and I am giving a np dot range in a histogram. See, now there are uh 10, it's like 20, 10, 10 beans. So 0, 10, 20. And if I make that plt dot xsticks also same way that I have made in last time, that at this particular positions. So see 0, 10, 20. Now you can see that how many people. So from 10 to 20, there was only one people. From there are 8 people who has got around from 80 to 90. And there also you can also this, so this is now there is no space. You cannot understand properly what is the particular thing. So what we can do is we can use another argument r width. Basically, we'll control the width of each bin. So I can give it 0.4. See, now you can clearly see that how many people are there in particular bins. If for 4, maybe it was too small, so we can have 0.9 basically. Yeah. See, now you can see that between 0 to 10, no people has gone below 10. From 10 to 20, there is one people and something like that. Okay. So between 60 to 70, there are 8 people. From 80 to 90, there are 9 people. You can similarly, I'm doing at X ticks. I can also do plt.y ticks also. I can say I can want to know from each one. So plt.y ticks, I can go from 0 to 11 at one gap. 0, 1, 2, 3, 4, 9, 6. And one more thing we can also do is that plt.grid. Here also we can see now that at each position, how many number of people are there. So here it is there, and we can control the different things in the grid. For example, one thing I generally use in the grid is alpha, because I don't want to be the grid to be very high. So I'll make the grid little bit of transparent. Maybe 0.1 will be sufficient actually. Yeah. Like 0.1, so that you can have a grid to look at, but it won't be a very what do I say, strict grid, right? Something like that. Okay, then give it like 0.95 also. Okay, so you can clearly see now. I can go and check it properly that at what point each of them are taking. Okay, and there was a small thing. It was there in the example, which is this one. So here, basically, these people in the particular thing, they have calculated it's kind of a normal distribution. So if they have plotted this distribution curve in this particular uh, thing. Okay, in this particular thing. So we can plot a distribution curve like that, right? With the mean and median. So that only the mean, median, and sigma and mu. That only they have used here. So here they have used something like y and add a best fit line. So basically they have did a best fit line with this. Okay. So if we can also do the same things like this. So this is the normal distribution formula to have a best fit line. We can also do this, very easy to do. And so we have just basically done this, and instead of making this as this, I can also make it as a variable known as beans. Okay. So now if I do this, something is sigma is not defined. Okay, sigma they have, I think, made the sigma somewhere here. Yeah. So they have done kind of a mean of this particular thing. So this particular average of this particular thing and standard deviation of this particular thing. And they have made kind of a normal distribution with the data. Okay. So this also is easy to do. Okay. Not very difficult to do. Basically, you have to make a mean size equal to 420. I think X we don't need here anywhere. X, Y, Z, no. So basically, you can always do a mean and standard deviation for this. So for example, sigma is not defined. We'll do the sigma and mu. Okay. So how do you do that? Basically nothing, but sigma is what? Standard deviation. So, and mu. So mu will be basically NP dot mean of NP dot array. Okay. NP dot array of this particular array of grades. And the people who have not very much familiar with NumPy, please, I have taught NumPy in one of my previous classes. Week 10, well, yeah, week 10 class. So yeah, I have gone through the basics on NumPy. Please have a look on those. That if you want to learn that, if you don't know how to use NumPy, okay. It's equal to, I think standard deviation will be NP dot standard deviation. Standard deviation in NumPy is np.std. Std of again same thing, np.array of grades. And now if I do bins is not defined. I have named bins. Okay, I have not bins. Define it quite early here. Okay, like this. Yeah, so it's coming something somewhere here because not properly plotted actually. We have to use everything of here, the features and all, then only we can plot, I think so. Actually, they have plotted here so basically it's a mean, so I have to plot the probability here instead of this thing. So you can see there will be a higher thing, but you cannot observe it here. If I do it in a separate thing, you can understand it very well. Yeah, so it is going something like this. So it's a probability distribution actually. It won't go here like this. So you have to make a kind of a probability distribution of this, then only I can plot it. Okay. Something like this. So it's kind of a distribution of the score. So they are more probable that you will get a score like this. It's a probability distribution. That's why we have used this particular format. Anyway, this is not very much needed. We'll stick still here. Okay. Okay, we'll stick till here. And yeah, so let's ignore this parts also. Okay, this was something of histograms. There are other multiple other things also which you can talk about Matplotlib. For example, one thing which will be very much, which is very much useful in our particular, in our what is the score now? Oh, they have made them all out. Great. I hope India again wins. So yeah, so we'll something known as subplots. Okay, the last thing we'll go about is the subplots. So subplots. So what is a subplot? So many times we will see that we have to plot subplots for a particular thing. I'll just show you subplots. Okay, and so this is kind of a subplots. Okay, so like vertically take many things, for many things we can plot a subplot, right? Sharing access, 1D array, something like that. We can do lots of things in subplots. Okay, so we'll choose something very simple of subplots. Okay, and for example, say in a same graph, I want to plot both the uh, x square, how the x square as looks like, as well as the how the log x look like. Okay, in a same plot. So I want to do something like in this kind of type of plot. At one side, I will have y is equal to log x and y is equal to x square, something like that. Okay, so we'll go for some xy values. So I'll go for x is equal to np dot an array, sorry, a range from 0, comma to 0 to maybe 2000 in 1. Okay, and what will be my y? So y1 will be x1 square, and my y2 will be, I think logarithm is, I think log in matplot, log in numpy will be np dot log. I think np log in numpy should be, yeah, np dot log basis e, natural logarithm. So it will give me the natural logarithm. Okay, I want to do the lnx. Okay, lnx. Can also do log 10, log 2, something like that. Okay, so we'll do the x square and lnx. Where is that? Okay. So np dot log of x. Okay. X1. Oh, sorry, x. Oh, sorry. Log 0 is undefined, right? You can do only from 1. Correct. Now I want to plot this logs. What for that? What I will use? I'll use fig. Fig is this particular figure. Fig dot x. I'll do two subplots. Is equal fig comma x is equal to plt dot subplots. Okay. One will have, say, maybe 2 row, 1 column. Okay. If I just run this, you can see there are 2 rows. Okay. This is your fig. This is your ax1. This is your ax2. You can always do is like something like this also. that is AX1, AX2. This will also give you the same thing. Okay, but I prefer to do it just in the previous way. I'll come to you in the next part. Okay. How do you understand which one is AX1 and AX2? So AX basically is, if we just run AX, it's basically an array, nothing but an array, subplot array. Okay. So this is, so how do you array, how you will index AX0? So I'll just change the color of the plot to make you understand how actually AX0 and AX1 works, axis one works. Okay. Something like, if I do this, access subplot dot and have access, 1 second. X dot face color. Set face color, sorry. The set face color. The set face color also set face color. Set face color. Now if we write again something like, and if you do this in a single column, so instead of doing this, so do it in single, this one. So this is your basically AXS first element. This is your AXS second element. Okay, something like that. Just for your understanding, I have did it like this. Okay, let me keep it like this to so that understand. Now in AX0, this one I will plot X versus X square. So what I will do, AX0 dot plot, I'll plot X versus X square, that is Y1. And X1, I'll plot X versus Y2. Actually, you have to do something like this to show the element. You have to do plt.show. So no, actually, you have to do it in everything. Is one go. This is one of the problem in this doesn't happen in this one. See, I'm seeing that this one, and I can make like color is equal to black. Color is equal to black. For both of them, I'm keeping it black so that it's easy to see it. Okay. See, this is how the log x works, and this is how the x square goes. So log x kind of goes up, then flattens up, and it's exponential growth. So it's going like something like this. Okay, and here it is actually going to 4 to the power e to 1 e6, something like this, whereas it's staying something within the so log 2. And also if you want to do it like this, you can also do it like this. So log 10 is basically so something like 3, something like that. Okay. Works. So this is how subplots work. Now, why I'm using instead of x1, x2 like this? So for example, I have 4 subplots. Okay. Basically, if I now run this, you will see that is basically have 1, 2, 3, 4 subplots. how do you define your 4 subplots? Again, we have 2 columns and 2 rows. So we have to make it here. So this will be basically my 0, 0, and this will be my uh, first, second row, first column. So second row, first column. Same thing will happen to here also. This, see, now the face color also changed. Okay. So this you can see that something is there, something like this. Also, say maybe I want to plot some more things. Y3. So what we can also do is that plt.subplots, there are some other arguments in plt subplots like share x or share y. Both of them are there. Share, if I make it share x equal to true, you'll see that now it has a only one shared axis for each of the graph. If I say also that share y is equal to true, you will see that axis is shared, and since this is like in 10 to the power 6, you can see that this kind of become a flat line, because if I, instead of log x, if I say x as cube, you'll see that, okay, like this it is happening. Okay. Okay. Yes. Why x cube is going to minus? Huh? What is my y2 now? Oh, okay, something in 10 to the power 6. That's why it's coming. Okay. Minus 1 to 10 to the power 6. Okay. Something like that, it will come. Okay. So example of how the subplots actually work. Okay. The subplots. And so that's more or less things that you can do with. There are numerous other things that you can do with Matplotlib. I've just shown you something like this. So if it's going to access the second and put some grid. Okay. Oh, sorry, it will be 1 1 1. So this has put some grid here. So there are multiple things can do with the subplots, and you can do multiple plots, because for subplots I have shown you, because many times we need to show same things in a one single graph. Okay. And last thing I want to just to the last thing just want to, before I finish off, that is the last one is the saving the saving figures. Okay. Okay. Saving figures. So for saving, we have to use the, and here also, sorry, and you are also like, you have to do everything with the AX format. For example, I want to set AX is 0 0 dot set X label which is set the X label, is basically we'll set the X label of square of X, something like this. And this is X10 will be X level will be natural log of X. Okay, it's actually as here square of X natural log of X. Since it's just a big file you cannot see, you can always make this size and all to make sure if everything fits properly. So for that, we have to plt.subplots, and we have to also use something known as fixed size. So fixed size, so width and height. So if I say it's say 12 cross 12, it's a very big figures have been now made. Okay, so 12 plus 12 figure, thing like that. So that now you can see everything is there. And if you want to do the title of the whole plot, so you have to use the command plt.subtitle, that is super title will be, say I'll just using subplots. Try to run again. So it's a subtitle it has put like pills and everything else is similar. You have to make, you can also do x ticks, y ticks, everything you can do in a subplot. Last thing is that used to use that plt.savefig. What we will do is plt.savefig. Okay. Let me see what is happening. plt.c you have to, so you have to give your name. So my name will be say example dot, you can do any type of format, you can do PDF, you can do PNG, anything. See if I do s1.pdf, I can set my DPI, that will be your say 300. Generally you use 300 DPIs and use that this. Also you can do fixed size also from here also. And if I now run this, I don't know, so it will be, you will get a, but it will be a I think it will be an empty plot. So what we have to do is we have to put everything in the same here, otherwise it won't work. Okay. Okay, and now if I do example.pdf, see we got the plot. Okay, like PDF, you can do PDF, PNG, whatever you want. Same way. Okay. So yeah, so that's more or less a few things that I will use that. I'll change this subplots and saving figures. Okay. This is not needed. Delete. Okay. That's all we have here for us. And this is how the matplots have, at least basics of matplotlibs I have taught you. You can always go to the matplotlib and go and search for, there are 1,000 things. See, these are how many things. It's a huge module. It's like matplotlib and I have just used some of them, or like matplotlib.pyplot. There are other modules in the matplotlib which even I also don't know everything. I have used sometimes matplotlib, but tickers I have used. Sometimes there are 1,000 others. There are something known as matplotlib tickers here. Tickers, you can do a tick formatting here. For example, say if you want to tick only in the particular format, and if I can show you one or two example, if it are shown, for example, fixed locator. It's a fixed locator. For example, you can call the first fixed locator. For example, I can show you this. So I have to first import this particular things. It is here. So I can first have to import it dot. This is a separate class in the as stickers sticker, and I can say, for example, in this one, say I want to use the ticker only. So I can use that ticker dot fixed in ticker dot fixed formatter. Yeah, fixed formatter. So it will be in, yeah. So it's fixed locator. Sorry. Ticker dot fixed locator. I can say I want to have a location of location. So plt dot xsticks is sticker dot fixed locator. I want to, you have to give it in a list format, say 1, 3, 6. It is coming. I think the problem is here. Just a second, let me check how to use the fixed locator. Looks nbin is equal to none. Jesus. Yeah. So, but example. Okay. We'll go for see some example. So I want to do a fixed formatter, fixed locate. Yeah. So we have to see x dot x-axis set measure locator. Yeah. So plt dot set measure locator. Yeah. So this we have to use. Start this. Use this particular. Basically, these things are easy to use in the these are easier to use in the the subplots. Basically, I am not sure if I can use it in the yeah. So basically, you have to use the AX in that one. So what we generally do is PLT. So we always write like this: pic, comma x is equal to PLT dot subplots 1, 1. So then we have to always do it like ax dot plot, because you have lots of things you can do with just a, making it x. This you can actually keep PLT also. Start legend. So x dot x-axis, and if you run this, name Matplotlib node array r. Sorry, this will be ticker dot fixed. See that I've got like 1 and 5 and 8. So if I want to do 1, 3 and 6, 1, 3 and 6. So sometimes you can need to change your this fix as 1 plot 1 because to use this particular, and you are plotting on the axis. So that's why you are making ax.plot, ax.subplot, and instead of if you want to use this, you have to always use x.set y label, ax.set x label, ax.title, something like that. Everything you can make it in x. Sorry, ax.set title. Everything you have to do is set here. Okay, something like that. So yeah, so this is how you basically use different subplotting. And I will just for your understanding better, I will not keep this here. I will make this in a separate markdown heading using tickers in subplots. Okay, there will be a separate thing to do. And I can also copy this here, plus here, this. Yeah, like this we can. Okay, instead of making everything, so we should go one by one. Okay. You can also, there are different types of formatters. So fixed function formatter, index locator. We have linear locator. There are lots of things of locator. You can also go and have a look in the Matplotlib, the ticker. This also is sometimes is used quite commonly. There are lots of other things that you can do with Matplotlib. So I have just gone very basics of Matplotlib. So that will be enough for you to plot simple small things. Okay. And for further any things, you can always have a look on the internet. Okay. This is how it looks like. So we'll stop for the time being here. And do you have any questions regarding this session? Any doubts regarding in this session, in this particular session? So if there is not, we'll meet for our last session on next Tuesday. Next Tuesday, the session will be from 4 to 6 instead of 7 to 9 because I have some meeting at 7 o'clock. So next Tuesday, last session will be from 4 to 6. Okay. Because I think there is another session from 6 to 8. So we'll have 4 to 6 hour session instead of 7 to 9. Okay. Our last session will be from next Tuesday, 17th October, 4 p.m. to 6 p.m. Okay. Thank you very much for joining. I'll end the meeting here and thank you. Yeah, surely. I'll share my Jupyter notebook. You will have this on the Excel sheet here. I can also share. I'll put the GitHub link and of the Excel sheet, and you can always have a look in there in the GitHub link. So as you know that here, if I share the screen once more, you know, right, that you can access all the things from your particular this thing. Like down here, problem solving sessions, recordings. Yeah. See if you go to this my particular GitHub, this one. You go to the GitHub, you will find all of the sessions. So here only I'll upload my this extra sessions, the Jupyter notebook also. Okay. Anything else? If not, then we'll stop here. Thank you all for joining and goodbye. Thank you. Thank you. Thank you. It was helpful for you. There are some I think there are some spots where I had also got stuck, small things. But yeah, so you learn by getting stuck, more and more stuck. So when I first thought of the sessions to do it in one by one, then I could not realize of some small things, but I realize. But as I told you, this is very basic. When you will be actually doing things, you will be you have to learn more and more things, so that you will learn, it will be a learning curve. And as you much do real life problems more and more, you will face real life problems in your daily job or your research work or in your coursework. You will start to understanding matplotlibs or any other modules, numpy things in those tricks in those things, new modules there in your life, in your daily work. Okay, thank you. Thank you all. So try and one more thing, try to do the matplotlib. Try to do solve things in Matplotlib, Google Colab or Jupyter Notebook, real life projects. It depends on your work. Some people, if you have lots of computations, calculations, I generally prefer to use a Spider. Now, if you have lots of visualization, Google Colab or Jupyter Notebook is good. So it totally depends on your need and whichever is comfortable. See, overall, if you write a code in Google Colab, if or you're in a Jupyter Notebook or in Spider, everything is just same. It's just the how you visualize or how you write the code at that IDE is different. Otherwise, there is nothing. If the same code, you can just download it and download it as a py file. So if you go here and you can download it. So for example, download as PDF, notebook, IPNB. You can also download it at .py file. You can download it at in as a .py file, open in Spider and run the codes. It will run properly. Okay, so you can do it. So whatever suits for you. Okay. Yeah, I mean different means you don't have, it's not different means the writing is different, but the in Google Colab also you can write a Python code or you can write a HTML code. You can use Visual Studio also. So whatever it you prefer to use. Some people used to write Python in Vim, Python code in Vim. The the thing that you get with Linux, the default thing that you get to Linux. Shared at 4:33. Yeah. Yeah. That is the this link. Yeah, this is the Matplotlib. Basically, it's just Matplot, pyplotlib, pyplot.plot. You can go to my Matplotlib, search Matplotlib, and it's nothing but it's just documentation of plt.plot basically. Okay. Okay, then see you. Goodbye.